This lecture is about social learning, the way we learn with or from others in our group. This is one of the most interesting topics. I took an entire course on social learning when I was in college. This is the book we used. I find this stuff fascinating. Now we need to go forward thinking about social learning in the context of simple, parsimonious mechanisms of learning that we've learned about from Thorndike and Pavlov and Skinner and Tolman and people like that. So social learning is about the transmission of information between members of the group. And animals that live in groups serve many functions. They fend off predators together. They hunt together. They can inform each other about good food sources. Animals live in group, facilitate mating. But we're going to look at some specific ways animals help each other to learn. Now, Thorndike was particularly interested in this, and he tried to do some research. Remember the puzzle box, and the cat presses the lever and gets out of the puzzle box. They want to get out. Well, he had one animal learn the whole trial and error process of getting out of the puzzle box. Learn by doing. The other animal did not do the behavior. This is fundamental to Thorndike's theoretical law of effect. Animals must behave and be rewarded for their behavior to learn. And so he had one cat watch another cat go through this process. Then he put this cat in and saw, well, is it going to learn faster? From observing, this cat could say, oh, I see it. I see how this works. I got to hit this lever, and I hit this lever, and out I go. But what he found was, even after observing another cat do this cat was put in and still had to go through the very slow trial and error processes of learning, which supported Thorndike's idea. Thorndike simply said animals can't learn by observing. They must show action. But there's lots of examples since Thorndike that seem to indicate that animals learn from each other. Chimpanzees learn tool use. Here's a chimpanzee fishing for termites with a stick and a little junior chimp watching him. Here's another crushing a nut with a rock, and here's a little baby, and they learn this type of behavior. One of the most famous examples are these little birds in England called blue tits, and what they do is they open up the top of foil on the top of milk that's left at people's houses. And it was observed that this would happen in only certain areas of England and then spread from there, as if, oh, only these birds learned from each other. We're going to talk about them. Another famous example are these rats. These black rats live in Israel, and they eat the pine cones in very specific ways. And the idea was to pull these seeds out of the pine cones to strip these scales in very specific ways, which made eating the nuts and the pine cones easier. They found that certain animals in their group would watch and they would strip the pine cones in very specific ways. Oh, observing another rat doing this. We're going to also talk about the sweet potato washing in macaques in Japan, a really fun story. And other examples that we're really not going to get to in this lecture are things like bird singing. Learn from parents how to sing songs, or migration and migration patterns. Birds that migrate really long distances have to follow other birds and learn the migratory routes. Not going to talk about that, but still consider a type of social learning. And finally, honeybees and the bee dance that they do. And these bees come back to the hive and they do these things called the round dance and the waggle dance, and other bees are around them, and the amount of waggling and the direction will tell these other bees where there is source of nectar and how far it is from the hive and how it sits in relationship to the hive, learning about sources of food from other honeybees. So, social learning has gotten a lot of attention from anthropologists who are interested in culture. Now, in humans, we have culture, which are typical behaviors, these are customs, these are our type of art, these are our sharing of information, sharing of beliefs and religions. And the idea is, are humans the only ones that show culture that is transmitted from generation to generation, or do animals do the same? Is this imitation? Is this monkey here understanding the processes that the other animal is going to and doesn't have to go through trial and error learning, which really violates some of the things we've talked about in terms of basic associative learning principles? Or can we interpret them in the context of theoretical law of effect and Pavlov's idea of contiguity and all those other simple, parsimonious ways of understanding learning? It might be that social learning is simply setting up circumstances that allow other members of a group to learn on their own more easily. So let's look at this. We have what's called social facilitation. One animal is in a group is simply making it easier for other animals to learn. They still have to go through the process of learning, trial and error, learn by doing, all those other parsimonious things. It's just living in a group makes that easier, more efficient, and the animals learn more quickly. Do the presence of others facilitate learning and not necessarily cause imitation or emulation? We'll get into those definitions in a bit. So let's start with one concept. It's called the local specific behavior. Patterns of behaviors that are only found in relatively small group of animals, implying a social influence. So, example, remember those birds, the little blue tits of England? The fact that only certain small towns had these birds that were pecking into the top of milk bottles, and it wasn't found across England, even though these birds are found across England, that's a local specific behavior. We'll look at some other examples. Chimps use specific tools in one area of the Gombe rainforest and maybe use other tools in other areas local to that group. Potato washing and macaques. Macaques are found in many areas of the world, but only ones that live on an island in Japan will show this type of washing behavior, locally specific behavior. So let's talk about the macaques. Macaques are kind of fun. So you may have heard of these Japanese macaques. They go to these hot springs up in the mountains. If they live up in the mountains, these hot springs with hot water, and they kind of jacuzzi and hot tub during the cold winter time. There's others that have been shown to wash their food before eating it. And those have been really set as the idea of animal culture. Here is a group of macaques that live near the ocean. They have a culture. Their culture is to wash their food before they eat it. So here's the story. In the 1950s, researchers wanted to observe macaques on the island of Koshima in Japan. But they're kind of hard to track down, so a researcher had the idea, hey, how about if we just put out some food? The animals will come to the pile of food and we can watch them there. Simple, right? And we can watch them interact with the food and it'll be nice. So they put out this big pile of sweet potatoes. And the macaques loved the sweet potatoes, and they came and they chewed and ate the sweet potatoes. And this little female that the researchers called Emo would take their little sweet potato and take it to the ocean, because they were in this big pile on the sand, and nobody likes to eat sandy sweet potatoes. So Emu, a brilliant little macaque, would take it to the ocean and would wash it off. Well, the ocean also had some salt, so washing it in the salt water, suddenly you have sweet potatoes, clean sweet potatoes with a little bit of salt. Delicious. And then what they found is that other members of this troop of macaques began doing the behavior. It started with Emo's mother. Emu mothers started taking the sweet potato and washing it. And the playmate of emu, they started to do this as well. Were these other members of the troop watching emu and goes, oh my God, emu's so smart. Look what emu's doing. I'm going to do that. I'm going to grab the potato. I'm going to wash off the potato and get some salt on it. Yummy. Emu was also doing another thing, because not only did they put out sweet potatoes, but they put out rice, big piles of rice. And emu, again, brilliant little macaque, would take the rice in their hand, take it over to the ocean, as long as there weren't like lots of waves going, and would drop the rice into the water. The rice would float, and all the sand and grit that were on the rice sank, and then she would just eat the rice off the top of the water. Again, a little brilliant macaque. And others started doing that as well. And they saw that these behaviors spread in this group and became a local specific behavior. Other macaques around the world wouldn't do this, wouldn't wash their food, but these animals did. Question is it an observation? Do they observe, or did emu just make learning easier for the other macaques? Here's a nice picture of a sweet potato and a little baby and a macaque, and a perfect opportunity for the baby to peer over and go, hey, what's going on? What are you doing? Ooh, I should do that behavior too. Is this social learning? Learning from observing others? Was it an imitation? Which violates these ideas of trial and error learning, which is so rooted in learning ideas of Pavlov. That an animal must do, must act, must behave in order to learn, and must be rewarded for it. They can't just look at something and say, oh, I see what you're doing, work it out in their head, and do it themselves. That violates Thorndike's theoretical law of effect. So is that what was happening? If it was social learning and imitation, here's what one would expect. It would arise by chance. Okay, emu did that. But then it would start off spreading slowly at first, but then show sort of a geometric or exponential growth. Because the more people demonstrating, I'm sorry, not people, but macaques, the more macaques demonstrating, the more observers, and the more observers would turn into teachers, and then that would increase. And so you would start with a couple, and there may be 2 or 3 doing it, now 6, now 12, now 24, and it would grow really rapidly. You would see this real rapid growth if it was observation. If learning on their own, then the numbers should change slowly over time. Every macaque had to go through the process of trial and error learning. Now, maybe emu and the others made things a little easier. For example, half-eaten potatoes were found by the ocean. The potatoes that they ate that were up on the sand were gritty and yucky, and the ones that they found down at the ocean, when they did the behavior of going down to the ocean, they would find a half-eaten sweet potato, they would plop it in their mouth, and it was so much more rewarding than the potatoes with sand on it. So now we have a behavior. Go down to the ocean with a potato, and you get more reward. So emu facilitated another animal to learn because there were potatoes down by the ocean, and those potatoes tasted better. Here's what Redron and Gallup observed when looking at the records of sweet potato washing in the macaques, 1953 up to 1958. And here is the learning process. Here's the washing, the animals who washed, and the animals that didn't wash. And we see that this was a very number of macaques, number of monkeys, a very slow process of learning. It wasn't the exponential learning one would expect if it was observation and teachers. More teachers, because they're doing it now, increased the numbers that could observe them, increased and increased. So one of the things that Gallup talked about, he said, I don't think we have imitation going on here. I don't think we have the transmission of culture. I think we have one smart macaque who made it easier facilitated the learning process, the learn by doing, the Thorndikean process, by just making it more rewarding when you ate a potato down by the ocean. So that behavior continued. It wasn't necessarily, hey, I see what Emu's doing. Emu's clever. I'm going to do what Emu's doing. I'm going to grab a potato, I'm going to go down and wash it. It was more of, hey, potatoes are down by the ocean in the water and they just taste better and that's where I want to be. Learn by doing, trial and error learning. Emu and some of the others, the more that did it, the more potatoes, half-eaten potatoes were found by the ocean, and that helped in the learning process. Before we must move past simple ideas of Thorndike, simple SR learning, we need to have a good reason, because we get into complexity, which assumes solving problems in the head, solving problems in the mind, rational thinking. Not saying that monkeys can't do this, but that's a leap of logic. So what we have here is what's known as stimulus enhancement. The potatoes are enhanced. They taste better. Emu's helping that process. When the actions of one group member makes it easier for others to learn. The demonstrator's behavior or location merely draws the observer's attention. And maybe Emu's down there chewing on a salty, clean potato, and some jerk of another macaque comes over and grabs it from her, sees it, attends to it, sees her eating it, grabs it from her, and starts chewing on it, and goes, ooh, salty, sweet potato with no sand. That's what I'm talking about. Attention is important in learning. And Emu and the other animals that were washing potatoes increased that attention towards the potato, towards the ocean, all those things, which helped in the trial and error learning process. One animal creates conditions under which others learn for themselves, even without the demonstrator there, even without watching the other animal wash potatoes. It just facilitates. Stimulus enhancement in a group helps learning. This is really important. This is the idea of the importance of learning in social groups. They help. Now, humans, we can get to the point where we can observe, and I'm going to give you some examples where there's some other animals that do, but we must move from the most parsimonious assumption to the most complex. Okay, now let's talk about the blue tits in England. Now, I like this story because I lived in England for a couple years, and one of the things that I just thought was so cool is we had milk delivered. And I'd wake up in the morning and I'd go out there and there would be a glass bottle with a little foil on the top of milk. And they delivered bread too, and it was so nice. They would deliver it to our flat and I'd bring it in and give it to the kids. And what they found in some parts of England was that this little blue tit, little bird here, would pierce the top of the foil with their beak, thin foil, and they would drink the very rich cream that would float to the top of the milk. And this only happened in certain areas, a certain small town in England. And a lot of these birds were doing it. And people said, oh, birds are learning from each other. They're going, hey, I see what that bird's doing. He flew down, he landed on that bottle of milk, he pierced it with his beak and he drank the milk. I'm going to do that. That's an imitation. Again, maybe it's just a situation of making things a little easier to learn for others around them. Facilitating the learn by doing process. So, milk is delivered, cream collects at the top. In the 1930s, they found that the blue tits started puncturing the top of the bottles. This became isolated, a local specific behavior. Cultural transmission, imitation. Wow, that's really complex. Birds are imitating. Culture, wow, birds with culture. That's amazing. Or maybe it's something else. Well, first, imitation isn't common in these animals. They don't really live in these tight-knit groups that we see. Other animals that live in tight groups are more prone to showing imitation behavior. birds could just be learning where to conduct these behaviors. So let's imagine a bird goes down and it happens to find a half open bottle and it drinks from the top. And now the bottle becomes associated with where to get food. This is just auto-shaping. The food is, the milk is drunk with the beak closed, and the bottle is associated with that. And maybe now there's been a few of these cases where these birds are opening up the top of these bottles, opening up the opportunity for other birds to come down, see the milk, see it, come down and drink it. Now we have an association. I see a bottle with foil on top. That's associated with food. I fly towards food, the unconditioned response, and now I fly towards the bottle. I put my beak into milk to drink it or water. I put my beak in the foil. The foil becomes simply an auto-shaping key light in a way. And the more birds that are opening up these bottles, it facilitates this association. Now there's just more bottles to drink from, more opportunities to make those associations. Could have just associated the bottle with food and began pecking. Natural response to the top of the bottles. Again, when you hear about these stories, people are saying culture and imitation and learning from others. And others, learning theorists, say, hold on, maybe that's what's happening, but let's look at more parsimonious reasons. Right? This goes all the way back to C. Lloyd Morgan and Tony the dog that opened up the latch. The passerby says, "Oh, I see, your dog understands how latches work." And Morgan was basically like, you didn't see the trial and error process of learning. This stimulus enhancement of bottles being open facilitates the learning process for each bird to learn on its own, not imitating others. Okay, so Sherry and Gallup tried to replicate what was happening with the blue tits in England. And so they brought this into a lab. And instead of having these big glass bottles, they used these little plastic creamers that you can find at like restaurants to put into coffee. And they used this really pretty little bird called the black-caped chickadee. Group 1, they taught a group, some of these birds, to peck and open this up. And they were observed by another group in the next cage. So they observed a bird opening it up, observed the whole process. And in group 2, they just learned to feed from open tubes and looked at the process of these animals learning to open up this container. And what they found was that there's really no difference between the groups. In other words, observing another bird did not help any more than just having a tube open and available to drink from and learn on their own. They simply replicated the idea that the blue tits in England are not observing and learning from others in culture. It's just facilitating the ability to learn. Stimulus enhancement. The bottles are just open and now you can drink from them and you learn on your own. Not necessarily imitation, certainly a local specific behavior, but not because of imitation, which is really a complex thing to assume. So the work on cone stripping in rats was again trying to say, well, the parents are teaching their young pups how to strip the cones in specific ways to get at the seeds. And this was thought of to be an imitation. Oh, I see how you're stripping them, the pattern in which you're stripping them to get the most seeds in the shortest amount of time. Partially stripped cones have their scales exposed, making them easier for young rats to gnaw on them. In other words, this is very similar to some assumptions made about the macaques. The older ones just simply would strip some of the cones, eat some food, and walk away, and the young ones would come and have an already half-stripped cone, pine cone that they could then start at that spot and move around the cone. In other words, the older ones were just making the trial and error learning by the young rats just that much easier. And it wasn't the idea that the young is saying, I see what you're doing, I see how you're doing it, I don't have to go through a trial and error process, I can just observe and learn. That's not what was happening here. It was just helping. Rats are also just attracted to other rats and other rat feces, and it just enabled and facilitated the rats learning because they were already half-eaten cones in a pattern, and the rats would learn trial by error, really to start at one side and move around in that pattern that didn't require observation. So observation learning is a leap in logic. It's a leap in assumption. So we need to really have some good experiments that can demonstrate it without being able to account for the behavior with basic ideas of stimulus response and Pavlovian association. One animal must observe another for learning to occur. The behavior or emotional affective state of the demonstrator is conditioned to the stimuli present. This is what I'm talking about here. Let me give you a very specific example, because this is really showing some observation learning. So mobbing behavior that birds do. Birds approach a predator in groups, and they yell and they scream and they squawk. Now, European blackbirds have to mob, they get into groups against their predators, which are like barn owls. So European blackbirds were brought into a lab. There were the teacher birds, and what the teacher birds did is they saw a stuffed animal. That's what they could see. And they would squawk and squawk and squawk, because that's an enemy. That's a predator. The pupil birds could only see the other blackbird who was squawking while looking at the owl. That's what they could see. They could see that emotional response. But the observer, the pupil, what they really saw was the squawking other blackbird, and they were staring also at a harmless little bird called a honeyeater. So now what they're seeing is a squawking, yelling, terrified blackbird member of the group, while they're looking at a honey creeper. In other words, do they learn to be emotional or terrified or threatened by a honey eater? When the pupil later saw a harmless little bird, it showed this mobbing behavior. So here is my kind of poor description, drawing of this. So here we have one blackbird, it's the best I could do, looking at an owl and showing this high emotional response. And here's a little blackbird looking at its fellow blackbird freaking out, learning that this bird is freaking out, but he's also looking at this little honey eater, little harmless thing. So he is learning from this one how to be scared of this one through simple classical conditioning, but it is observing. He's observing another, a conspecific, we call it, which is the same species, another blackbird freaking out, but he doesn't see the owl. He sees only the honey eater. So when he sees the honey eater in the future, he mobs it. He shows the mobbing behavior that they would normally show to an owl. There was some observation here, an observation of an emotional state. Okay, let's look at another experiment. There's been a few with these little monkeys called marmosets, kind of cute little things. Huber did a number of these experiments. I'm going to show you one of them, Volker and Huber. And it really kind of shows something that we can't really account for with Thorndike and Pavlov. It shows imitation. So here's how it works. They trained marmosets to open a canister to get a treat. And they train them in one of two ways. You can get to the treat by opening the canister with your mouth. That's how you get into it. That's group 1. Group 2, they could only open the canister with their hands. Now, both of these groups were observed by other marmosets. Some marmosets were watching the mouth opening ones, and some watched the hand opening ones. Observer marmosets watched them. And when the observers could open up the canister on their own, they tended to do the behavior that they watched. The canister could be opened either way, open with the hand or open the mouth. But if you watched another open it with the mouth, you tended to open it with the mouth. If you watched others open it with their hand, you tended to open it with your hand. The observers observed and imitated the methods of the other monkeys. So here's a little drawing. Here's a marmoset opening it up with the mouth. Here's a marmoset opening up with the hand. And if one group of monkeys watched this monkey, they tended, when given the canister, they tended to open it with their mouth. If another group saw this monkey opening it with their hands, they tended to open it with their hands. That's not trial and error learning. That's imitation, because they could have done it either way. And it's not really local enhancement because the stimulus enhancement, because the stimulus is the same. If they're focusing on this little canister, great, that's drawing attention to it, but they're observing specific behaviors and imitating those behaviors. And finally, this is a rather interesting experiment to look at not only imitation, but what is also called emulation. And I'll give you the definition of the two. Imitation is doing the exact behavior that is observed. Emulation, or what's called goal emulation, is to observe the ultimate goal and then doing the best way to do that, doing the performance that gets you there. Seeing what others are doing and their ultimate goal, and you just get to that goal without necessarily having to do the full behavior. So here's an artificial fruit experiment. So there's this glass or plexiglass container, and inside is a treat. And there are two ways of getting into this. Both are perfectly reasonable. One is you twist open these bolts. Twist open the bolts, you get to it. Another way is you got to poke the bolts forward. Poke them. So twist them or poke them. Either way, you're going to get in there. And they did this. They had a demonstrator either turning the pins or poking. And these were observed by chimpanzees and children, young children. Open using the same technique in front of the subjects. So one group of children and chimps, they only saw the turning. And another group only saw the bolt poking. 8 chimps and 3 groups of children, 2.5, 3.5, and 4.5. And then they were videotaped when they were doing this whole experiment. And they had other people who didn't know what they had observed. In other words, you have a group of people watching the video who didn't know whether the chimp saw turning or whether the chimp saw poking or whether the kid saw turning or poking. And they just simply said, what method are they using in the video? Not knowing what they had observed. And here's what we kind of find out. We found that those that watched the poking tended to poke more, and those that watched the twisting of the bolts tended to do the bolt more. This became more and more true as the children got older. They tended to imitate what they saw. But we also saw this in chimps, just not to the same degree. Subjects of both species were significantly more likely to use the action they had seen than the alternative, though chimps showed kind of less fine level of accuracy. Chimps did direct their behavior to the correct part of the box that they were doing. they were supposed to do, the twisting or the turning, even when they did not use the same action or behavior. So there was a little indication of imitation. Now, what we also see is that children tend to imitate. They tend to do exactly what they see adults do, adult humans do. There's some evidence that chimps can kind of bypass the imitation and really just get to the goal emulation. That they imitate the goal, or they replicate the goal and not the exact behavior that is shown. So while there is some ongoing evidence that animals, especially animals living in groups, have the ability to imitate, learn by watching others, a lot of the early experiments or anecdotes about imitation in animal culture, like the macaques, like the blue tits of England, I think we should be evaluating them first. Can we explain it using just trial and error learning without leaping into a logic of solving a problem in the mind, observing, put yourself into that person's position or that other animal's position, see what they do? That's really complex. I still think there's a lot of research to be done on imitation, goal emulation, and social learning.